See, in the previous videos, so we have seen how to sample, okay, sampling theorem we have seen. So in conversion of any analog signal to digital, the first step is sampling, that is what we have seen. So this will only give you continuous signal to discrete, whereas the second step is called quantization. So we will see in this class, in this session, so what is quantization, so and what are the different types of quantizers available. So conversion of analog signal, analog samples of signal into digital form is called quantization process. So in the sampling, what we do, we are going to get the samples at regular intervals of time. Here I am getting what is a sample, next at this point I am getting what is a sample, again at this point what is a sample, but still they are represented in terms of continuous. So I want to map this to some digital data. For example, if the sample value is this, so I will map it to 101. If the sample value is this, I will map it to 110. If the sample value is this, I will map it to 111. So quantization, so which means that, so I am going to assign a binary value to each and every sample values, each and every sample values. The amplitude of each sampled value, I am assigning a binary value. Therefore, I am approximating the infinite number of levels. We have infinite numbers from here to there. Okay, from here to there you will get maximum infinite number of samples. So that can be quantized, that can be represented as a different levels. So that is called quantization. So now we can classify this quantizer into broadly into two types. One is uniform quantization and other is non-uniform quantization. So on what basis we are classifying them as uniform is the step size. Okay, suppose if you take what is the step size, that is this value. Okay, this is one by quantized value, this is the other quantized. The difference if you take and this difference if you take, they are all same. This is called step size, normally which we represent it as delta. So when the step size, the difference between one level to the other level, if it is constant throughout the amplitude range, then I call it as a uniform quantization. If this step size is not constant, it is varying, this is different from this, then I call it as a non-uniform quantization. Let us now see what is uniform quantization. So uniform, as I said, so the step size should be constant. So throughout the complete interval amplitude range, so the step size is constant. Such type of quantizers we call it as uniform quantization. Again in uniform we have two types. The first type, what we call it as Midtrade Quantizer. So what is this Midtrade is? So before that, so let us draw the transfer characteristics of your Midtrade Quantizer, and this is x-axis indicates the input, y-axis indicates the output of the quantizer. Input of the quantizer means a message signal. If your input is between minus delta by 2 to plus delta by 2, so the output is 0, correct? Or when your input is 0, output is also 0. So when your input is between minus delta by 2 to plus delta by 2, as marked here in the red, so minus delta by 2 to plus delta by 2, so the output is 0. Okay, so mathematically we can represent G of NTS means it is the sample values of the input signal. If the input is lying between minus delta by 2 to plus delta by 2, then output is how much? 0. Output is 0 for all this range. Okay, so where delta, if I call it as a step size of the quantizer, which is constant because it is uniform quantizer. Okay, so next I will take the next interval from minus delta by 2 to 3 delta by 2, the second interval, this one. So minus delta by 2 to plus 3 delta by 2. When the input is between that, so the output is delta. So the output is delta. Mathematically same thing can be expressed when the input is between delta by 2 to 3 delta by 2, output is delta. Okay, so similarly you can obtain the other levels. So when the input is minus delta by 2 to plus delta by 2, as shown here, the output is minus delta. Okay, like this. So you can write all the ranges. Okay, this is called Midtrade Quantizer because so the output is 0 when input is 0, exactly at the origin. So when the output is 0, so input is also 0, and hence it is called Midtrade Quantizer. This is about the transfer characteristic of input versus output of the quantizer. Now let us look at the error. What is quantization error is? See, when the amplitude or the input signal is having at this level, when the input is this exact value, same thing if the output is also mapped to the exact value 110, then there will be no error because input is equals to exactly mapped with the same output. Similarly here if you take, so this input level, if your input is this, so output I am mapping it to 101. So that is exactly mapped to that level, therefore there is no error. Suppose if the input is at this level, now there is no predefined level for this, therefore what I do, I will round off to next value or the previous value, whichever is closer. So when you are rounding off to the actual next value or previous value, so you are either, this is represented as either 110 or 101, but the actual sample input signal either not equal to 110 but also not equal to 101. So but I am equating to, so the either previous or whatever the next values. So actual value is different from what I quantized. Okay, so this difference I call it as quantization error. So now I will define what is quantization error is. Epsilon I represent. Okay, so this is output actual value, the quantized value minus the actual input. If I take the difference, I will get the error. So if the input is same as quantized, then error will be 0. Okay, so now when you say g of NTS is 0 at this point, if you say when you are at the origin, so when input is 0, output is also 0. When input is 0 and output is 0, 0 minus 0 is, so you get 0. So that means that error is also 0. You can observe here. So error is also 0. Next, when I take, when your input is delta by 2, okay, when your input is delta by 2 or less than that, so your output you are quantizing to 0. So therefore the difference is delta by 2 minus 0. So you get maximum value, that is delta by 2. Okay. So when your input and output are same, error is 0. When you input and output you have a difference, okay, delta minus delta by 2. So you get delta by 2 is an error. Similarly on the other end, so this is actually minus delta by 2, but you have coded to minus delta. Therefore, so the difference is minus delta by 2. So you have a maximum error that you can get is either it will be minus delta by 2 maximum or maximum of delta by 2 in general. So I will call it as maximum error is magnitude of delta by 2, maximum error that you can get. This is about Midtrade Quantizer because so when your input is 0, output is also 0. Next we will see the other type of uniform quantizer, so which is Midrise Quantizer. So what is the difference between Midtrade and Midrise is when your input is 0, output was also 0 in Midtrade, whereas in Midrise it is rising to the next level delta by 2. When your input is 0, output is not 0, so it is delta by 2, or it may reach to minus delta by 2. Therefore, mathematically we can represent when the input is between 0 and delta, that means this value. When the input is between 0 and delta. So what is the output? Delta by 2. So your input is between this, but I am getting output as delta by 2. Similarly, when the input is between 0 and minus delta by 2, okay, sorry, 0 and minus delta, this value, so output is minus delta by 2, that what I am coding. Okay, so therefore, so output is delta by 2 when your input is 0 to delta, 0 to minus delta. Okay, so this is minus delta. Okay, therefore GQ of NTS is minus delta. So this is called Midrise Quantizer because amplitude is either plus delta by 2 or minus delta by 2 when your input is 0. It is rising. When the input is 0, the output is raised to next level or previous level. Okay, this is called, hence it is called Midrise Quantizer. So similarly, if you want to look at the error, it is output minus input, right? So that is GQ of NTS minus G of NTS. So when the input is 0, when G of NTS is 0, what is the sampled value? So it is plus delta by 2. Okay. So therefore, when your input is 0, output you are coding to delta by 2. Therefore, delta by 2 minus 0. So you get it as delta by 2. So again, the error can range between minus delta by 2 to plus delta by 2, and the maximum error you get is at the 0, because when your input is 0, I am coding it to plus delta by 2 or minus delta by 2. The maximum error that you can get at 0. Okay, so again it reduces to, it keeps on increasing. The error becomes 0 when your input is delta by 2. I am also coding the amplitude output at delta by 2. Therefore, error, if you take the difference, it is 0. Therefore, at this point, you can observe it is 0. Okay, so the maximum error that you can get, so is delta by 2. This is about quantizer. So uniform quantization, the different types of quantizer as Midtrade and Midrise Quantizer. Thank you.